Welcome. This is Wayne Thompson from KRW Electronics, and today we will be reviewing the STEM Activity Manual. The STEM Activity Manual is a manual written to allow students and of course any science enthusiasts to link theory with practical. There are a lot of theoretical textbooks, there are a lot of physics books, a lot of chemistry books and stuff like that, but there are not a lot of books that talks about using the concepts in the textbooks in a real world practical manner, and of course also giving you a comprehensive activity review as well. So the STEM Activity Manual is geared towards just that. So this is a current design of the STEM Activity Manual. As we say, it's a manual. So the concept of the manual is that students will write in it. So there are plenty of activities students will write. They will perform calculations. They will observe robotics motion. They will measure displacement and time, and they will plot graphs. And from the graphs, they will come up with equations. So from the graph, they will come up with equations. Now these equations can then be tested. So basically then the robot will be allowed to move in accordance with these equations, and then it can be tested. So for example, what am I talking about? So say you get an equation for a particular robotics motion. What you can do is allow the robot to move, and at a specified time you can measure the distance. That time you can then put in the formula to see if you get the right calculated distance. So you would have a measured distance and a calculated distance. So these are some of the activities that are done in the book. Now, while the robot is also moving, if the speed is changing, you know that the kinetic energy can be a function of time as well. So we can talk about what would be the object's kinetic energy at a specific instance in time. So the object of the book is really to allow all of the concepts that students are learning in, say, physics classes and math classes. They'll have a practical medium in which to do the activities. So in terms of what is in the book, the book has now 12 chapters. Chapter 0 is introduction. So that talks about the general introduction and the general ideas behind the book. Chapter 1 talks about distance. The concept of distance is explored, so students will do a lot of measurement. There will be a lot of robotics movement, different types of movement, moving in straight lines, moving in different paths, moving along different trajectories, and students will do measurement, and also they'll perform direct proportion calculations. So they will talk about one wheel rotation and the distance that gets you, and therefore how far will two wheel rotations get you, all of that stuff. In terms of displacement, the concept of displacement will be explored practically. So through a series of activities, the concept of displacement will be explored, and students will have a hands-on way of understanding and appreciating these things. The next topic, graphs and robotics. Well, what the students will do, they will get information or data from experiments. What type of experiments? Motion experiments, of course. So for example, the robot will be allowed to move for a specific time interval, and at short time intervals, students will be asked to record the distance traveled, and then now they'll plot graphs. So when they plot these graphs, then now they'll be able to do graph analysis, and a lot of those analysis are in this book. Students will explore the concept of speed. Alright, so the robot speed will be varied. So the robot will be at one particular speed, and then will change the speed, and of course students will perform activities where that is concerned. So with speed, we talk about acceleration. So students will be allowed to engage in acceleration activities, and of course momentum, where momentum is just the mass times the velocity of the object. So it is a very hands-on thing. Students will be able to write in the book. Alright, so it's a workbook as well. And moving on to chapter 6, you have kinetic and potential energy activities that students will do. And then what we did was to reserve a chapter for problem solving. So students will be given different types of robotics motion from the formulas and algorithms, or the different algorithms that they will be given. Or the teacher can then also come up with different algorithms and types of movements. And so we have a sequence of problems that students can solve. Alright, so we have problem solving as well in terms of force and motion using robotics. Alright, we have algorithms to allow students and help students to explore that. Log graphs and robotics. So basically, from the data collection sequence, if the student gets a curved graph, what they can do is that they can convert it to a linear graph, and then they can also use this to do lab experiments, and they can also use this to come up with equations for a particular motion. And as well, they can also see that what they're learning in school now, so students normally do logarithmic graph in school, they can see a practical and hands-on way that this is done. So logic gates and robotics, students normally ask, what the zeros and one means, but now they can see that these sequence of zeros and ones now can control objects in real life, can control devices. And so while teaching logic gates, the educator or the facilitator, the teacher, what he or she can do is that they can also allow the students to engage in activities that will bring out the concept. So this is our idea of STEM or STEAM, where you're talking about science, technology, engineering, the arts, and mathematics. For the arts, what's not necessarily covered in this book, but will be covered in other series, is that we will want to bring in the arts. Then now, how would we bring in the arts in the other series? We know that there are a lot of art students. There are a lot of persons who are good narrators and who are good reading students. So how the arts will come in, we'll bring in the arts, all right, through animation. We'll bring in the arts through drawing and all of that creative learning. So that is how we'll bring in the arts. So there are a lot of different ways that arts come in, and I'll talk about that in the algorithm series. So for quadratic equations, we can allow students to explore quadratics, or to show them the relevance, that math has relevance. So basically, based on the outcomes of a quadratic equation, I can allow those outcomes to control real-world devices. And that is the concept that we have drafted to link what they're doing in school, concepts and formulas and algorithms, using computer science to control real-world objects. So that is what you can expect in the 4 chapters. So the next thing that we're going to be talking about, the STEM code package. Of course, this will allow students to be engaged in critical thinking, computation thinking, and of course, problem solving. And of course, that was an example of one of the sessions that we did using robotics. We were able to derive an equation for the motion by observing and gathering data. So this is the scientific process. So students they're acting like scientists, they're being a scientist, right? Because by the act of observation and analysis and recording information, then now we can come up with a lot of equations. The STEM code package, mathematics formulas, controlling lights, robots, and other devices. So basically based on certain mathematical outcomes. For example, if say the pressure is greater than say 100, the pressure calculated is greater than 100 pascals, for example, then now under those conditions I can allow a robot to be switched on, or lights to be switched on, or other devices. If, for example, we did Pythagoras' theorem, we can say that if the length of the hypotenuse side is say greater than 10, we may want something to happen. If the length of the hypotenuse side is less than 10, we may want something different to happen. So basically also, we can also allow the software to display the step-by-step sequence in solving the problem. And also what the step-by-step sequence will do, alright, students can also see that now the final result can be of use. No longer does it have to be, okay, we do perform our calculations and it's just a number on paper. This number on paper can have real-world consequences. So it's about linking abstract with reality. Some persons view mathematics as abstract. So this is why we coded hundreds of mathematical formulas, and these results of the calculations and the computations can give us real world indications. For example, compound interest. We may want to be notified every time, all right, compound interest is greater than a certain value, say 100 or 1,000. So every time that happens, we can control the robot. We may allow the robot or a TFT screen to display certain information to the customer, all right, or we can also equip it with other technologies. So that's the good thing about using the Arduino platform. We can change the features, all right, that we want at any given time. All right, so if, for example, compound interest is say greater than 100, we can allow it to the Arduino software system to say send a phone call to the customer or display a text message, etc. All right, so that's the concept. What is the rationale? We just want students to see. We want them to appreciate mathematics. We want them to appreciate the sciences, and we also want to see to show them that what they're learning can have real world consequences. And also, this can be an enlightening period whereby students can say, okay, all right, I am going to set up, say, for example, an accounting system, and for example, I will, have it a software. So when I put in certain parameters and certain calculations, or I don't know, I have I'm controlling real devices, and these real devices are telling me or showing me, all right, that certain things happened. All right, so that's the concept. Physics formulas controlling lights and robots, similar to what the concept of mathematics. And then now to get the other subject areas involved, we actually say, okay, keywords. So we ask a question in the Arduino IDE software, and if the students just input the correct string answer, all right, so normally we allow the answers to be, say, one word, all right, so it's not too complicated, so to input a long sentence, so one word. So the correct answer, of course, can control different devices. So it's like a password access system that we have devised. So this can be used as a game. Basically, we can allow the robot to respond to specific answers and give unique and exciting features as well. Alright, so for the STEM activity package, so these were just some highlights of working with these sessions. These are some of the technologies that you will need or use, especially the Arduino kits. We have written thousands of codes to deal with our STEM strategies, and these are some of the different types of robot we use, and of course a lot of it is redesigned so that we get the type of capabilities and the features that we want. So we do the modifications to the robots, design some from scratch as well, and of course all of the coding is done by us to achieve what we want. The next one is, say, the underwater robots. All right, so the STEM activity series, this is another thing or robotics package that we will be covering as well. This is not currently in the STEM activity manual. What we will do is, I think we will want to do the underwater separate from the land. So we're going to be talking about that in a little bit more detail in the future. But in terms of underwater robotics, these are the type of topics and the list of topics that we will use those to cover. All right, so thank you for listening. So this is a book review of the STEM activity manual and the vision for the STEM activity manual. All right, so you will see and hear more about this concept in later videos. Until then, I'm Wayne Thompson, CEO of KRW Electronics and STEM engineer, a robotics engineer as well. So